All right, here's our notes on section 1.5, complex numbers. So we've got imaginary numbers here. Um, and up at top, we have a Venn diagram kind of showing what's going on. So complex numbers are going to be the ones with A. A is our real portion of the complex number, plus BI. And again, I is the imaginary, and B is going to be that coefficient there. Um, so real numbers, I guess, technically fall into this set of complex numbers. Their real numbers are just the ones with a b coefficient of 0, because 0 times anything, even if it's imaginary, is still 0. And so we got the real constant, or not constant necessarily, but or yeah, constant there. Plus nothing is just the constant is a. Now, pure imaginary numbers don't have that real portion. It's 0 plus whatever the imaginary number is. All right, so let's go and take a look at some of these. And first here, we're going to be, got a little diagram to help you with imaginary numbers. And so I guess let's start at 0. Anything to the 0 power is always 1. And just to actually, yeah, we won't go into the reason for that right now. But I mean, think through if I had something divided by itself, like x to the 5th power over x to the 5th power, we know that would be anything divided by itself is 1. But also that these coefficients, those exponents, so that's x times x times x times x times x over x times x times x times x times x. That cancels with that, so x divided by x is 1, x divided by x is 1, x divided by x is 1, and x divided by x is 1, leaving us with x to the 0, and we're set. That's probably more information than you wanted, but there you go. That was for free. So now the imaginary numbers here, again, anything to the 0 power is 1. And I to the 1st power. So now what is I itself? And I is defined as being the square root of -1. And the reason this is imaginary is that if we have any number, think of any number that could be inside of here, like 4. That is, the square root of 4 is 2. And there's a primary root and a secondary root. When you're solving and you have an x value, make sure you get your positive and negatives. But when you're just simplifying, all we want is the primary root, the positive version. And now 2 squared, if I were to square that, gives me this number right here. It gives me 4. But there's no number that if I square it, that I can end up with a negative inside of here. Regardless of what we do, if we start with a -2, for example, and then square it, that gives us +4. Or if we start with +2 and square it, that gives us +4. We can't get a negative inside of here. The only way to do it is to have an imaginary number, and that's why I is defined as the square root of -1. All right, now even though that's imaginary, if it gets multiplied by itself, so I squared is going to be equal to the square root of -1 times the square root of -1. And when these multiply together, we get, well, the square root of anything squared is itself is that radicand, and so we end up with -1. I squared equals -1. So imaginary number, when it gets, so I, that imaginary number, when it gets squared, gives us back to this real number, so -1. And now when we multiply it by I again, so now I to the 3rd, we have I times that -1, so I to the 3rd. We knew I squared was -1, and that's times another I, so this is -1 times I, or just -I. I to the 3rd is -I. And lastly, we multiply that by one more I, and we get I to the 4th. Now that's I to the 3rd times I, and remember I times I, that's really just -1. And so we end up with -1 times -1, which is +1. And we kind of have gone full circle now, and now we're back to 1 again. And that's going to be the case with imaginary numbers, that they do cycle through. Every 4 you end back up at 1 again. So to the first power, and to the 4 more than that, to the 5th power would be right here, and to the 9th power still be all at just I. So I to the 9th is exactly equal to I to the 5th, because 4 of those i's is really just 1, and this is really just equal to I, because 4 of those i's is again just equal to 1, and 1 times I is just I. Let's go through and kind of sort this all out now. So we're going to write it in terms of a radical. So I itself is the square root of -1. I squared, we said, is the square root of -1 times the square root of -1, which is -1. I to the third is negative square root of -1, which is -I, most commonly written that way. I to the fourth, well, that's back to just 1 again. I to the 5th, and now we start the cycle all over again. I to the 5th is going to be the square root of -1, or just I. And I to the 6th moves on to the second part of the cycle, and so it's going to be -1. All right, so the value, to write this more specifically, the value of I to the nth repeats every 4th power. Every 4th power. So the cycle being wherever we start from, so or actually start with 1. So we'll start with I to the first would be square root of -1, or just I, then -1, then negative square root of -1, or -I, 1, and then back to the beginning of the cycle again. So square root of -1, etc., etc., etc. So really, if you just take the power, whatever the power is, and we'll do this in the next set, but let's kind of explicitly say it right now. If you take the power, whatever n is, divide it by 4, and then just look at your remainder. So if the remainder is 1, you're at I. If your remainder is I. If your remainder is 2, you're at -1. If your remainder is 3, you're at -I, and if your remainder is 4, then you're back at +1. All right, I hope that helps.